All right, so today we're going to be covering Chapter 3, Lesson 8, Solving Equations and Formulas. So what we're going to learn today is how to solve equations for given variables and how to use formulas to solve real-world problems. So some vocabulary is dimensional analysis. Um, so this is an equation that we might look at today where you'll notice is that there's multiple variables in it. And multiple variable means that different variables, right? Different letters. So when we're going to be solving for variables, some equations, such as this one above, have more than one variable. And at times you will need to solve for one of the specific variables. All right. So sometimes they'll have a solving for G or H or V, right? They'll pick one and we have to solve that one. So let's look at an example. If we were asked to solve an equation for a specific variable, this could be an example of something you'll encounter. So it says solve 3x minus 4y equals 7 for y. So here's my equation, 3x minus 4y equals 7, and I need to solve for y. And if you remember, solving for a variable means that you're going to isolate the variable. So here I am. Here's the original equation. If I'm solving for y, that means this is the variable that I'm trying to get by itself. So I got to get rid of this, right? How do you get rid of the 3x? You're going to subtract it, right? So I'm going to subtract 3x from both sides. And when I simplify that, that's going to leave me with negative 4y, right? And then on this side, I'm going to have 7 minus 3x. These cannot be combined because they both don't have x's. So I'm just going to go ahead and write them the way it is. So now, again, I'm solving for y. What do I need to do? I need to get rid of this negative 4. Well, right now that means negative 4 times y. The opposite of multiplying by negative 4 is dividing by negative 4. And I got to make sure to do it to both sides. So once I do that, these negative 4's cancel out, leaves me with just the y. And if you notice on this side of the equation, there is nothing I can do. I cannot simplify this any farther because of this variable, and that's okay. Right? When I'm dealing with formulas or equations with multiple variables, a lot of times there actually is no computation to do. You're just writing out your steps. All right. So this, one thing we could do, right, is if you notice, if you divide everything by a negative, right, you'll get positive 3x minus 7 over positive 4. So that's all they did is they basically took everything and they multiply it by a negative and then they put the variable up front. So this will become negative 7, this would become positive 3, and this would become positive 4. And again, they just flipped it around. So this is kind of the simplified version of what the answer would be. So now we know that the value of y is 3x minus 7 over 4. So it's sometimes helpful to use the distributive property to isolate the variable for which you are solving, right? So we've talked about the distributive property before, so we're going to utilize that today. So here's an example. So solve for a specific variable. So here we have 2 times m minus t equals s times m plus 5. We're solving for m. So now you notice m is on both sides of the equation. So we want to get it all on one side first. So I'm going to go ahead and get rid of this one on this side. So I'm going to subtract sm. Okay. So I'm going to take my original equation. I'm going to subtract sm from both sides, right? Sm minus sm will zero out. And it leaves me with 2m minus t minus sm equals 5. And so now, again, to try to get the m's by themselves, I'm going to get rid of this t here. So the opposite of subtracting t is adding t. So I add t to both sides. It simplifies to 2m minus sm equals 5 plus t. And again, if you notice, I haven't done any calculations because they're all variables, right? There's nothing to compute. Now this next step is probably the one that people find most challenging. If you notice, I have m here. Well, normally if it was like 2m minus 1m, right, I could do that because 2m minus 1m is 1m. Or if I had 5m minus 2m, that's 3m because I know 5 minus 3 is 2, right? But here I have 2 minus s. I don't know what s is, so I can't actually do that, right? I can't just combine these. So what I'm going to do is I'm going to use the distributive property, but in reverse. Now I notice that both of these have m. I can factor out or divide out the m, and it leaves me with 2 minus s. Now some of you may say, like, how does that work? Well, it's really just the distributive property backwards, right? So if I took this and I move this over here, and I said, let's look at m times 2 minus s, right? If I were to say to multiply that, you would say, I can do that. I'm going to use a distributive property, right? I'm going to do m times 2 and m times s, which would give me 2m minus sm, which if you notice is what we started with. So really, we're using the distributive property, but backwards, right? Since both of these have m in common, you can use it backwards. You can divide out the m, which would leave me with m times 2 minus s, right? It's the distributive property. You can use it forwards or you can use it backwards. So again, let's go back to the problem. So that's how we got from here to here is we use the distributive property backwards, right? We divided out the m, which got us here. And then again, if I'm solving for m, I want to get rid of this parentheses. So the opposite of multiplying by what's in the parentheses is dividing by what's in the parentheses, right? And if you notice, these will cancel out. It leaves me with just m. And on the right side of the equation, I don't know what those variables are, so I can't simplify them any farther. So that is my answer. M is equal to 5 plus t over 2 minus s. So in this scenario, s could never be equal to 2 because if you have 2 minus 2, that's going to make 0 in the bottom of a fraction. And if you get 0 in the bottom of the fraction, if you try to do that in your calculator, if you try to divide by 0, you always get an undefined number or answer. Your calculator might tell you syntax error or division error or 0 error. So it does give you an undefined number. So s can never be 2. Let's go ahead and talk about using formulas. So many real-world problems require the use of formulas. Sometimes solving a formula for a specific variable will help you solve the problem. So let's talk about in May 14th of 1898, a severe hailstorm hit Kansas City. The largest hailstorm or hailstones were 9.5 inches in circumference. That is really, really, really big. The windows were broken in nearly every house in the area. So let's look at this example here. So we're going to use a formula to solve this problem. It says use the information about Kansas City hailstorms to the left. And it says the formula for the circumference of a circle is c equals 2 pi r, where c represents the circumference and r represents the radius. So here are what we're going to do. It's going to ask us to solve the formula for r, right? So we got to solve this equation and get r by itself. And then we're going to use that to find the radius of the large hailstones that fell in Kansas City. So let's go ahead and look at the original formula, and we're going to solve it for r, which means we're going to get r by itself. Well, r is currently being multiplied by 2 and pi. Well, I can get rid of those at the same time. What's the opposite of multiplying? Dividing. So I can divide by 2 pi because those will cancel those out. And again, as long as I do it to both sides, it's going to work. And when I simplify it, it just tells me that c over 2 pi equals r. So the radius is equal to the circumference divided by 2 pi. So now I have my equation that I can use. If I want to find the radius for the hailstones that fell in that storm, I know the circumference is 9.5, so I can put in the circumference in the equation and find out what the radius was. So let's take this equation. We're going to plug in 9.5, right? That was the circumference of those hailstones. And then I'm going to simplify and solve. So 9.5 divided by 2 pi, right? Put that in your calculator. And that's approximately 1.5. So the radius was approximately 1.5 inches of those hailstones. So that's how you can use a formula to solve a specific problem. So when using formulas, you may want to use dimensional analysis to process the units that we're using in the computation. So using dimensional analysis, we're going to use the formula s equals 1/2 at squared, which represents the distance s that a free-falling object will fall near a planet or a moon in a given time t. In the formula, a represents the acceleration due to gravity. So s is the distance, t is the time, and a is the acceleration due to gravity. Okay, so first thing we're going to do is we're going to solve the equation for a, and then in part B, we're going to find a free-falling object near the moon that drops 20.5 meters in 5 seconds and find the value of a, the acceleration on the moon. So let's go ahead and do a. So here's my equation, right, that they give me. Now I'm going to solve for a, which means I got to get a by itself, right? So I got to get rid of this fraction so I can multiply by 2. And I got to get rid of this variable here, which means dividing by t squared. So I can do those individually, right? I can do those individually, or I can do them at the same time, which to save myself some time, I'm going to do that, right? So multiplying by 2 and dividing by t squared, right? So multiplying by 2 cancels that out. Dividing by t squared cancels that out. And it's going to leave, and as long as I do it to both sides, it'll remain equal. So that will leave me with just the a. Again, this cancels out the fraction. This cancels out the t squared. And then on the other side, I have 2 times s, so 2s over t squared. So now I've solved for a. And again, you could have done this in 2 steps. I did it in 1. And now we're going to solve b. So for the free-falling object near the moon, it drops 20 meters. So that's my distance s. In 5 seconds, that's my time t. And I want to find out what a is, right? What's the gravity on the moon? So here's my equation that I did over here. I solved for it, right? So I'm going to plug 20.5 in for s, and for t, I'm going to put 5. So let's see. So I have 2 times 20.5 meters over 5 seconds squared. So let's go ahead and simplify this. 2 times 20.5 meters is 1.64 meters. Or sorry, 2 times 20.5 divided by 5 is going to give me 1.64. And I have meters over seconds squared, right? So this actually can be written as 1.64 meters per second squared, right? That's the acceleration due to gravity on the moon. So the acceleration due to gravity on the moon is actually much less than it is here on Earth. All right. So thank you guys for watching, and let me know if you guys have any questions.